I hope you have coffee with you, and yeah, let's start with some short introductions. To my person, my name is Christian. I'm project manager and of course Java developer. I joined MicroStream in 2019, and mostly I've done a lot of projects with MicroStream for the Allianz German insurance company and also for the German airport, Fraport, and yeah, we use MicroStream a lot and it works great. So let's see what we can do for you. I hope so. Do you already started projects with MicroStream? Some of you maybe?
Yes, I use MicroStream in production with a heavy load and lots of data.
Okay, great. So let's see. Okay, let's go further. That's the timetable. I think that's not so important. As I said, let's do the important topics first, and then we see maybe we can shorten that a little bit and skip some topics which are not that much important for you. Okay, these are the topics for today. I want to start with a small warm-up project. Maybe we can do that directly together. I think that makes more sense when we are a lot of people, but yeah, maybe we can skip that or do that directly together just to do the basic stuff. And then I want to talk a little bit about configuration and in detail more advanced configuration, especially the housekeeping. I think that's the most important point at this topic. What does that mean? How does it work? And maybe we can also have a short look to the channels and what channels are together with MicroStream. And I guess one of the important topics are also the advanced storing topics. Talk a little bit about eager and lazy storing. What are the differences between both strategies? Maybe we can, or we have to talk about transactions and some rollback stuff, and also exception handling. And I would say, let's have a look to the best practice in that case. So then we have lazy loading, and I think that's always an important topic, how to handle a huge amount of data, for example, how to use lazy loading in a proper way. I prepared a small example for you with 3 or 4 different strategies, so you can choose one for your projects. I think that's also, sorry, a great topic. Then we have to talk about concurrency. This is also quite important, especially with MicroStream, because all of the people and all of the users, I would say, or concurrent users, whatever, working on one object graph, and that is why you have to take care about concurrency more than usual. Then this is the reason why we have that topic here. Then we have the legacy type mapping, and I would say, or what does that mean, legacy type mapping? It's, yeah, what happened when a classes changes, or what happened when the data structure changes, what to do. I also prepared some examples for that. And then we have some really special stuff. For example, how to, why to use or when to use a custom type handler, for example, or when to use a custom class loader and custom store behavior. You will find all these topics and explanation also in our documentation. But I would say this is these customizations are topics that we can skip if you want. But yeah, let's see what we do. Then I brought a performance demonstration. Maybe some of you haven't seen that in the past, and I put this at the end of the training. So if we have enough time, we can have a look on that. but yeah, maybe it's not that important for you. And of course, we have question and answers, and I think that is one of the most important stuff of the training. So whenever you have questions, feel free to ask. So ask as many questions as you can. It's a training for you, so you should. Hopefully, I can bring you all the answers you need, and all the stuff you want to know. You can find the documentation here on doc microstream.1. It's directly also on our homepage. Shouldn't be a problem. I will post that links also to the chat. That might be helpful. So give me to all in the meeting. So this is the link to the documentation. Then we have two GitHub links. One is the link where you can find all the example project we process here in the training. It's my GitHub account, and there is also another GitHub account, which is the account of MicroStream. Give me just a second to copy the link. Where is it? Resources, examples. Here we are. Gone. Yeah. That is the third link. Okay, this is the official MicroStream GitHub. And also there you can find a lot of example projects and a lot of stuff regarding lazy loading, for example, especially that bookstore demo is a great project to find stuff which can be helpful for your projects. Okay, I'd like to summarize MicroStream a little bit for some of you that they don't know what MicroStream is. Of course, it's an advanced training, but maybe you start with that. And so basically, MicroStream is a Java framework. You can use it in every project which is built with Java or Kotlin or something like that, or Android. That's also possible. It's basically from scratch invented object graph serialization. That's what MicroStream basically is. And this object graph serialization, that means we are able to serialize a graph, a Java object graph, directly to the hard disk. That is the main store target, I would say, but it's also possible to serialize it to many different other storage targets like AWS S3 or any blob storages, some relational databases. Yeah, you can do that. You can send that wherever you want, I would say. And it's in the end, it's a binary format. You will have a binary format on the hard disk, for example. Yeah, this is what I said. You are also able to Kafka, DynamoDB, and so on. A lot of different store targets. And I think the most important thing is that you will be able to update these serialized data on the storage partially. That is, I think that's the special point on MicroStream. And this is the reason why MicroStream becomes more and more a database in the end. Yeah. And also it's an in-memory database, I would say. So that means it keeps the most of the data in the RAM. And this is also the reason why we have to talk about lazy loading, especially when you have a huge amount of data, then you have to deal with lazy loading. Yeah, but let's come to that later. You don't need any data mapping. So this is just take your POJOs as they are. So we will see that also in my examples during the training. We have only pure Java basic POJOs, I would say, without any mapping annotation and so on. But if you have some annotation, they will also work. So that is, you can use any other helpful annotations you have. It's totally up to you. Okay, in the end, you change the data in the RAM, and MicroStream takes care to keep RAM and storage synchronized. I think that's the easiest explanation of what MicroStream does, basically. So yeah, just to summarize that. Okay, let's switch to the first topic for today, the configuration. Yeah, definitely. We will use a lot of Java streams within that training. Is that okay for you? Because Java streams are the only way to get the data out of MicroStream, so we will use only Java streams for that. And this is working really, really great. It's our query language, I would say. So for that reason, we need Java streams a lot. So, okay, let's do a small warm-up project together. And I do this warm-up project for two reasons. The first one is most of my projects are based on Micronaut. So, and I use this project especially for checking out if the project is running on your PC, do all the configuration stuff on your side that you are able to code along with me during the advanced training. And maybe I should switch my resolution, right? So it's a little bit small for you. Give me just a second, and I will change that. Okay. Here we are. Maybe that's better now. Is that okay? Can you read the stuff on the screen? Okay, great. You will see a lot of projects here, and I would say it doesn't matter with which IDE you use. In my case, I use an Eclipse distribution. It's called RapidClipse. I use mostly Eclipse for my development stuff, but it's totally up to you which IDE you use. The first project is a car exercise project. And as I said, we will do that directly together. Give me just a second. I will send you the link to the GitHub repository. Here we are. Repository. Car exercise. Okay, here's the link where you can find the project. And that project consists of two branches. The first one is the master branch, and the second one is the start exercise here. Yeah, sure. I will zoom into when we have some code, or give me just a second. Oh, I need to find the right. That should be okay, right? So, okay. Okay, you get the link. So just check out that project. And the master branch is the finished project. Everything is in place. So also the code is there. And we can do that together. Let's start at the branch start exercise here. There is a branch named start exercise here. And let's do that together. Let's code along together. And let's try to start the project in the end. And maybe we have to change the ports on your side. Then we can do that together. So the only thing you have to do is just check out the project. There are some small classes in it, and you should have that application class here. It should look like this. And Let me just check. This is the master branch. I will also switch to the developer branch. Sorry, to the start exercise here branch. Okay, here we are. And then you should be able to start the project with run as Java application. And it should look like a little bit like that. There are many more possibilities to start that Micronaut application. So when you are expert in Micronaut, do it in the way you want. It's just for the training, a short explanation from my side. So, but you can also do it by your own. So, there is one question from Kieran. If I have to check if I get it right. As far as I know, there is no reactive programming used in MicroStream, but I'm not really sure. I have to check this with my colleague. But let's get into it. Maybe you will get the answer later on. So otherwise, I have to check, or I have my ask to colleague. Okay, so try to start the application itself. Maybe you have to change the port. It's the default one is 8080. You will be able to change that. Just go to there is one file, it's called application.yaml. It looks like this. Just a second, open, oh, that's the wrong one. Open with the text editor, it should look like this. And you should be able to start or to change the port when you add the following lines of code. Just a second. Oh. Okay. Where is it? Okay. So when you want to change the port, do some blanks here. That's important, and add the following lines. So let's say server here, and then always 2 blanks, and then let's say port 8070, for example. Just add these lines of code if you need to change the port. And after that, Micronaut will start on the port 8070. Let's give it a try. Oh, did I miss something? Port, I need, yeah, I think I missed the blank here. Yeah, no, that's should be right. Oh, did I miss something? Micronaut server. Oh, it worked a few minutes ago. I don't know why it's not working.
Christian, you should probably move line 4 one tab.
Another one?
Left. One tab left. And server should be at the level of application, probably. Line 4 is it one tabulation. So server would be at the application level. Server.
Ah, okay, got it.
Yeah.
Like this, right? So
no, left.
Left. I've tried this before.
Yeah. Try that.
Like this, right? So
yeah.
give it a try.
Try that.
Now it's working. Great. Thank you. So this is the way to change the port. Maybe Kieran write down this should also work. Let's give it a try like this, right? So let's run. Yeah, that also does the trick. Thank you, Kieran. Okay, we have another attendee, Alfrevich, is that right?
Yeah, sorry for being late.
Alfrevich, okay.
Yes.
Great to have you here. We
you.
already started with a small warm-up project. You can get it here on GitHub. Give me just a second. I will share the GitHub link again.
Mm-hmm. At first, I thought this was waiting to let you know that it's delayed again for not enough people.
Yeah, we moved. Yeah, but we moved it, and I don't want to cancel it now. So
yeah, it's okay.
Okay, this is the link. Okay, here's the link again to the GitHub repository. So get the project here, and then we can do some small warm-up stuff. There's another attendee. That is great. Hi, welcome to the training. Nice to have you here. Oh, left. Okay. So just check out the project and go to the start exercise here branch, which is specially made to code along together. So give me just a sign in the chat when I can start with the coding. You should be able to start the application itself. As far as I know, you have to enable the annotation processing of your IDE. That should be enabled, otherwise it will not work. So for so in Eclipse, you will find that by Maven, I guess, annotation processing, and you have to choose one of that, experimental or automatically, and then Micronaut will also work when you start the application class. You should see this, and then the application should be successful up and running. Did you all take part on the fundamentals training, or some of you started now with the advanced one?
I did the fundamental.
Okay.
Don't really have my working laptop here, so I'm going to see if I manage to set up everything quickly for the actual development.
Yeah, no hurry. We have enough time.
Yeah, but it's an ancient, since it's a vacation time, I'm at my parents' place, so there's an ancient device here. So let's see how much it cooperates. It's about, I don't know, 11, 12 years old thing.
Okay.
So yeah, I promise nothing.
Okay, as far as I know, there is another fundamentals training in November, I guess, the 8th and 9th of November, and also 15 and 16 of November. So there is another fundamentals if you are interested in. But I think we cover all also all that, most of the basic stuff also during the advanced training. So that's totally okay. So as I said, if you have some trouble with the ports to start the application, you can change it within the application.yaml file. Just to add line 4, as you see it here. So that would be, it would be great if this is working on your side, because most of the application for that training are, or all of them are based on Micronaut. So you are able to do the same stuff as I do during the training. So that would be helpful. If there are any questions so far, so feel free to ask at any time. There is one question.
Yeah, yes, one question.
Mm-hmm.
Well, I am a heavy user of MicroStream, and I master most of the API,
Mm-hmm.
and maybe I have 1 year's experience, so I feel MicroStream is great. But the biggest problem is I have to compare MicroStream to a relation database.
Yeah.
I have to handle index transaction and persistent data collection, such as a list, a very big list or very big map. So I suffer performance issue and transaction issue in the production environment. So I have handled update the index and also keep synchronized with the index and the data.
Okay.
So I feel it's very hard to make MicroStream just like a normal database. And yeah, I think it's the biggest issue for me to use MicroStream.
Yeah. Okay. Yeah. Okay. If I would say, let's have a look to the examples I brought forward today, and maybe that's helpful for you. And if there are still any problems on your side, maybe if you have some special requirements and so on, I think it would be best to make an appointment, only you, then you can share your code and so on, and then we can have a look to your code and try to find a solution for that. Also with my colleague Florian, I think he's really great to find solutions for that. Let's do it like this, I would say. So if you still have any questions after that training, let's do this in a one-by-one meeting, and then you will be able to share code and so on.
Okay.
Okay, there is one question to what is the differences between Quarkus and Helidon to Micronaut? That's a good question. Basically, all that 3 microservice frameworks do basically the same. Some of you might be more familiar with Micronauts, some of you more with Helidon. That makes no differences. We have a MicroStream integration in both systems. So, and we also have an integration to Quarkus, or it's on the way at the moment. So I think we are currently working on that. But for Helidon and for Micronaut, it's already available. And but basically all that 3 microservice frameworks do the same. Basically, the API is a little bit different and the documentation is different, but yeah, it's up to you which one to choose. Okay, can you start the application itself? Are you able to start? Or are there any problems so far? No problem. Okay, great. Maybe there is, regarding that question from you, depending on that performance issue and the huge collection and so on, and also lazy and synchronized stuff, on MicroStream version 8, we are, at the moment, we are working on a solution specially for lazy collections. So that means whenever you use that type of collection, you can stream through that collection, and it will be the collection handles that lazy loading stuff internally. So that means you are able to set the range or to set the amount of the amount of data which should be loaded at once, and then the collection handles that lazy stuff internally. That's a really great collection, and it will be available on version 8 of MicroStream. Maybe that could also help you to realize what you need to do.
Yeah, let me try. Yeah, because I am pushing the data size to 100 gigabyte, so I'm not sure.
Yeah.
The lazy collection can handle. But I will try.
Yeah, that's really interesting, because yeah, we also have a project with that database size, and you have to think about what data should be in the RAM, which one can be loaded lazily. So sometimes you have to do some trade-offs between performance and or you have to separate the data into different parts. But yeah, let's see. I come to that later when the lazy part of the training is coming. Okay, so let's start with the coding part of the warm-up training. So, and I'm going to start at the DB class, and let's add some parts that we need to have. And I think one of the most important thing we need is the storage manager, or especially the embedded storage manager. And in my case, I will be initialize this thing here. So let's say public static, and then say the embedded storage manager. Where is it? There is it. There we are. Embedded storage manager, and let's call it storage manager. So I think that's the most important stuff, and I would call it the database management system. So the storage manager takes care about the storage itself, and whenever we want to store data, we have to use that instance of the storage manager. And Another thing we need all the time is one, or maybe sometimes are multiple root objects, but in this case we have only one root object. That is the first entrance object of the whole database. And in our case, we will use public, come on, public final static company, and that is a company object. Let's call it root, and let's say it's a new company. So that is also, in some cases it's different. Some people like a root object which is not part of the data structure itself. And in my case, there is only one company in this application. So that means the database is only made for one company, and that's why any information or every information is part of the company itself. And that is the reason why this company is also my root object. So let's create a static block here to initialize the storage manager. And we do that, let's say storage manager equals, and there is the first possible way to initialize, or in my opinion, the easiest way to initialize the storage manager. So we need a storage configuration. So we pick that here, embedded storage configuration. And there is a builder method. And based on that, we are able to create a foundation. So, and that's all the time, that's the same way to initialize MicroStream. So first of all, we need a configuration. Based on that configuration, we create a foundation object, and based on that foundation, we create the embedded storage manager. That's the same all the time. Then we hand over the root object to the storage manager. And at the end, we say, start the application. So whenever we touch that class, because it's static, so the storage manager will be initialized, and we are able to get access through the DB class to our database. And you can do this in many, many different ways, depending to your application itself. That is really just normal, straightforward Java stuff. And some of you might say, okay, I don't want a static instance of the storage manager. Then you can do whatever you want. So it's just for the training, one example how to create a storage manager. But the important thing is we need that storage manager, and we need a root object, and we have to hand over that, and after that we say start. And that's all we need in the DB class to initialize a MicroStream storage. Okay, you have that?
Yeah.
Okay, great. So then let's move on to the domain classes. They are still in place. So we have the company class itself. We have the car. So that means that the data structure is still in place. So let's have a look to the company itself. As I said, we only handle one company in that application. So that means we have the name here. And as you can see here, we have brands and cars. And we have, of course, a list of cars in it and a list of brands. And as far as I know, we have also the brand. The brand is part of the car itself. And I did that because sometimes you will have a list of all brands in your application. And let's imagine when you delete the last car of a special brand, you would also lose the brand when you just have the brands here in your car itself. So that for that reason, I have a list of brands here to cover that problem. So then I can have brands also without a car. That's the reason why I have that here. But these are the same references. That means it does not doubles the amount of RAM we need because both the collection and also the brand of the car references to the same object all the time. So you have to keep that in mind when we add a car with a new brand, for example, then you have to add the brand to the car and also the brand object to the list of brands. I think that's important in that case. Okay, really straightforward data structure here. And now let's move on to the brand controller. And this is the functional part of the application. So where we can get all the brands, for example, via browser, or you can use Postman for that also. And let's take care about the code within the get brands method here. Just a second. Okay, so this is really straightforward to get all brands. So we go to our DB class and say db dot give me the root object because that is the company, and then give me the list of brands, and I have to return this, of course, and that's all I need in that method. So in that, give me just all the brands. So let's have a look to my Postman. I will need that. So. Okay. Let's have a look to the next method here to store a brand or to add a brand to the application. So the first thing I would do is to search if the brand is already existing in that case. And that's the first part we use the JavaStreams API. That means let me go to the root and let's go to the brands. And let's say, okay, stream. And in this case, you would be able to use the parallel stream because we have to find only one brand in that case. So it will be possible to use the parallel stream. It would be much faster then. And then we say, okay, let's filter it. And let's say we use the brand object itself. So let's say brand.getName dot equals ignore case. Let's do this down here. Okay, let's say db root get brands. Then let's stream through that in a parallel way, and then say, let's say filter, and let's find the brand equals ignore case. And then I have to say brand get name. It's the data transfer object here. In this case, I keep it simple. It's the same object itself. It's not a different one. DTO get name. And then I say, oh, here we are, right? find first. So that means whenever we find a brand which has the same name like the brand we hand over to that, then we will get the optional, and we have to check the optional here in this case. So let's say optional brand in that case. So I think that's really straightforward. You can use also the normal stream. You don't have to use the parallel one. It's also possible to use the normal stream. And we have to filter, and let's say equals ignore case, and then let's get the name of the transfer object. And after that, we have to check if the optional brand is present. That means optional brand is present. And we have to set that to false, I would say. And then we are able to create a new brand. So let's say new brand. Let's create a new one. And based on that new one, we say, okay, set name. And then we can have the .get name. And that's all we need. Let's have a short look again to the brand itself. So yeah, it only contains the name. So I kept it simple here, or I kept it simple. And now the first important part starts, how to store the brand now. And this is also quite easy. Let's say, let's go to the root object, give me the brands, and then I have to add this brand to the collection. Make this, don't need the outlines, or make it a little bit bigger. So, okay. Then we have to store that brand, and as I said, always store the object which has changed. That's an important rule to handle MicroStream. And in this case, we changed the collection of brand because we added one, and that's why we have to store the collection itself. And then because of that, I say db.storemanager.store, and then I take this part and copy that. I have to store the collection itself because the collection has changed because we added the brand to that collection. So then we need to return something. Let's say HTTP response, and let's return an OK in that case and hand over the new brand we created. So let's say brand. Otherwise, we would return an HTTP response, and let's say dots. Not allowed could be possible. Not sure if that is brand. Let's say dot not allowed. I have to just check if that is the right response. Okay. Because it's already already available, or one brand is already available with that name. Any questions so far? As I said, this is really basic stuff, really basic MicroStream stuff, just to bring all of you to the basic level, I would say, to start with the extended topics.
It's okay for me.
Okay, so let's try it out. So start a project and let's see if we can add some data. Application is here. Let's start the application. It's up and running, and I prepared this in my Postman. So that means I created a folder which is here, car exercise, and then just a second, all brands, I have it here. It's a get request, and I changed that to 8070, and let's say brands, and when I say send, I will get an empty collection. Status is 200, okay. You can also do this within your browser. So just do it like this. Let's say localhost 8070 / brands, and it should return an empty collection. It's the same result like this. So to try it out, just start the Micronaut application by switching to the application.java class and then say right click run as. It depends a little bit on your IDE, but start this as a Java application. And if everything is all right, you will get these console output. So as you can see, I used the latest version of MicroStream here. In this case, it's the version 7.1, the newest one. And I would suggest to use this one because that's the first version where the garbage collection finally works in the right way. So that is really successful for us to get it to run in that way. So the versions before, we had some issues with garbage collection and with concurrent stuff, but now this is working really great. Let's jump back through the classes. We have the DB class here with the storage manager instance, with the root object, the instantiation of that both objects, or especially here in this case of the storage manager. Then we have the domain class is already in place. No problem, Karen. Take your time. Yeah, that's what I'm. Yeah, let's go back to the brand class, to the brand controller. That's what I've did. So I negate this. So you should add that exclamation mark in front of. So let's try to add the brand, if that is working also on my side. Let's use the postman for this because it's a post, and you will only be able to add a post via postman, I guess. But I have to create a new one. Let's close. Yes, do the changes. Okay. Add request. So let's change this to post. Then we have local host. We can do this. Brands. I think that's the same. Yeah. Insert we have. So that means brands/insert. That's the right URL. And then we have to add a body. Let's choose the raw one and let's change this to JSON. And then we have to add a JSON format, but that's the easiest way. So let's say I guess it's name. That should be like this. Oh, all the time. Insert cars. Let's have a look here. Okay. Let's copy this. So, okay. So name. And we don't need that anymore. Okay. And let's say Mercedes, for example. Okay, we have this URL. The port is the right one. We have post. We have a body with raw, and we changed it to JSON. So let's try to add this to the collection, and it returns 200 okay with the new brand. Let's try to add this a second time. Let's check if that is working. That should also work. You will get a method not allowed because it's already in place. And when we call the all brands, we will get the Mercedes. Yeah, great. This is working as expected. So I can send you also the JSON part here. That's the URL on my side. Maybe you have to change. Maybe you have to change the port. In your case, you have to use the port 8080, for example. It depends on your configuration. And now we should be able to, let's call this add brand. Okay. Let's add some more brands. Let's say BMW or Audi or Ford. Let's add some more brands. And there they are. Here they are. Let's jump back to the code. You have the possibility to see the code again. So if you have finished that, you can do the same in the car controller class. There are also some methods which should be filled. We also can do this together. Let's do this a little bit faster to save some time. So, there's my, yeah, here we are. So I just copy and paste things a little bit. So in that, to list all cars, that is really straightforward. Let's go to the root and get the cars that you already have. You already have done this. Then the next one would be interesting to find a car by a model. And we used a get, and I also prepared the postman for that. But in this case, we also using Java 8 streams. So when we start to try or to get the data, so let's go to the root, get cars dot stream. In this case, we will also be able to use a parallel stream. Let's search. Yeah, it would work. Parallel stream dot filter. It's always the same with the Java 8 streams. Let's say car. Let's call it car, and then we say car dot get model dot equals ignore case. It's really the same like we used before to find the right brand. And let's say model. It's just a string. And in the end, we have to say collect collectors dot to list. Collectors dot to list. Okay. Collectors. Yeah. This is the right one. To list should be in uppercase letters. Okay, that's it. That's the stream to find the right car by model, or find multiple cars in this case. So we have to add a return, and then we can delete this one. So in this case, we directly return the cars we find here, or we return an empty collection. If you couldn't find any car by model, so it will return an empty collection. And it's really the same in the next one by brand. And that's why I will copy that also. It's the same. So that means let's get the cars, say stream filter, get brand, get name equals ignore case, and then the brand. Hi, Michael. Nice to have you here. So we already started with doing some warm-up stuff with MicroStream and so on. And if you want to code along or go through the code together with us, I will share you the GitHub link. Then you will be able to follow. Should be here. This is the link to the GitHub project. Just open your IDE, check out the project, and you can use the master branch to read all that's the same stuff we are working on at the moment. So do we have any questions so far? We created the car controller, I should better say we entered code to the car controller, and also we entered code to the brand controller, which is here, to get the brands and to insert a brand. And we have to do the same on the car controller side. So list cars, try to find some cars by model or by brand. And then we have two more interfaces, I would say. And let's get into it. So let's have a look to the clear cars method. That's also interesting because we haven't that case so far. So just to clear the list of cars, it's that simple. So just clear the cars collection in the RAM. And then, of course, you change the cars collection itself. And that means you have to store the collection in the end. And this is the reason why we say, okay, storage manager.store, and we hand over the cars, the car collection. And then we add the right response. Okay, cars cleared successfully. That's really straightforward. So let's have a look to the insert. And as I said, it's the same like on the brand side. I will just copy paste the code to that method. Of course, we have to look for an already existing brand in that case, because when we hand over a car which contains a brand already, then we have to check if that brand is already in place. And if not, we have to create it. Otherwise, we have to choose the brand which is already in the database. So in that case, I search for a brand which is part of the data transfer object here. And if the brand is present, then I will get the brand from the optional object. And then I have it here. And with that brand, I can create a new car, set brand, set model. And then I took the model from the data transfer object and also set it to the car. And it's the same again. We just get the cars collection and add the car to this collection. And after that, I have to store the collection itself. It's the same like in the branch, like with the brands. And as I said, it's always the same. It works all the time the same when you work with MicroStream. It's just changing your RAM and store that part of the RAM which has changed. That's all the time, it's the same. It is really, really easy to handle. And some of you might say, okay, what happened if the brand is not in place? So that means if so, and then you are right, we have to add this, this else. Yeah, what to do in that case? Then we should create a new brand. So let's say new brand. Then we have to add the name, set name, get brand dot get name, and then we have to store the brand to the collection of brands db root dot get brands dot add. Then we have to add the brand, and then we have to store the brands. And so on and so on and so on. It's totally the same. And after we store the brand, we can use this new brand object within our car. So let's finalize this. Store and then say get brands. That's it. Now we have stored the brand. And after that, we can use this code, create a new car, set the brand, and also store the car. And then we have to return the car itself. So in some other cases, let's return HTTP response dot. Let's see if there are some. Yeah, let's return just a server error. It doesn't matter. Ah, okay. Ah. Then let's say no. It's just for training purposes and should be okay. Okay. Yeah, that's okay. So we don't need that. Something you want to know? Any questions? If not, then let's try it out. If this will work to add some cars and to handle those brands we have. So give me just a second. I need my Postman. No, I don't need that. So Postman is here. We already checked the brands. So let's check if the brands are, oh, I have to start the application itself. So let's go to the application, run as Java application. I have to save that. And give me just a second. I want to change that from that server port. Makes things easier for me. Run as Java application. So Micronaut is up and running. So let's go to the Postman. Check if the brands are already in place. 8080. Oh, moment. Add brand. That was the wrong one. So let's check all brands. 8080. Okay. Here we are. These are the brands. Then we have the insert car method. It's also a post method. I will copy paste you that if you need this, that JSON part. And then let's add a model 330. The brand is BMW. Maybe we have to write this in uppercase letters, or not sure about that, or let's check that. I think we used equals ignore case, so that will also work in the end. Status is 200, okay. And let's get all cars. And then we have our model 330 BMW. Let's add another one. Insert car. Let's say model is 220. Name or the brand is Mercedes. For example, CLA. Let's get to all cars, and here it is. And this should work on your side, the same. And then we should also be able to say, okay, let's get a car by model. So in this case, we have the get here, and this is the URL. It's a little bit different. We don't use the body for that. And let's say by model, this is the URL, and then we say, okay, this is the variable, and the variable or the parameter, and we say model should be 220, I guess. So then we should find our Mercedes again. For some of you, if you are interested in where the database is and so on, when you open the project itself, the car exercise project, and you will find a folder directly created within the project itself. So let's get into it. Show in System Explorer here. This is the project itself. And after starting the application itself, you will find a storage folder directly. And inside the folder, you see the channel 0 folder and also the persistence type dictionary. And this is where the data are. So this is where the data is stored on the hard disk at the moment. We will have later a short look to how to configure that. We will be able to configure this, but this is part for later on. You can also give me just a second. Which style do I use? That's a good question. It's Java and Java editor font. Could this be right? It's the standard one, right? So it's nothing special. Editor, Java editor text font. Edit. Yeah, it should be this one, Consolas. Not the font? Code style.
Not the font. For the library and the package, and yeah, the if else position.
The colors and so on, right?
Not color, not color.
The style of your Eclipse.
You mean about rapid clips, the question, or maybe that confuses him?
The bracket positions? Okay, the
rapid clips, I mean, maybe he's not used to it, or
give it that is the code formatter. right? So maybe this, where is it? Code generation. Give me just a second. Formatter. This one, right? So
Yeah.
how the code is formatted.
Yes.
Ah, okay. That is an that is our own. I'm not sure if. Yeah, maybe I can forward this to you. But I have to find it. I don't know. I don't know at the moment where to find it. But let me take a note, and I will send that for you to you.
Okay, thank you. It's very special. I never seen this code style before.
Now I changed something. What did I change? I think I changed the color a little bit. That is best effort. Java code. Oh, no. Ah, that will. I changed to black. I have no idea how to change that back. Ah, okay, that's great. So let's do it like this. Okay. Sudon, can you send me an email, please? And I will send you that that formatter. So just
Okay.
Just a second. I write you my email address, then you can send me. Okay, this is my email address. Just send me a short email and I will send you the formatter. Okay, any further questions to the MicroStream code itself, to the warm-up project? Does everything work for you? Or do we have any problems to start the application or something like that? Okay, so no questions so far. Then I would say, let's make a short break, only 5 minutes. And then I will start with the very first new topic, the configuration stuff. Let's go on. And let's talk about some advanced configuration stuff. I think in the most projects, we don't use any or that many special configurations. Most of the stuff are really straightforward, or you can keep it as it is. I think the most important ones are the store target, for example, or the right URL or the right address to store the data. I think that's the most configuration stuff. But there are some special you need to know, and I just want to go through some parts which could be interesting for you. So the very first important stuff is you will be able to change any naming of your data which is inside the database. So that means, for example, you will be able to change the naming of the channel files here. You will be able, for any reason, you are able to change the name of the persistent type dictionary and so on. That everything is possible, and you will find all the information to configure MicroStream also within our documentation. So all the different properties which are available here, you can change. And there is also all the description of all the changes and what it does and why to change and so on. You will find that directly in our documentation. So this is nothing special, and to be honest, I never changed the name of the files here, but it's possible. The first thing which could be interesting for you is the channels stuff. Channels are the number of I/O threads we use to write down the data. And that could be helpful, especially when you write down huge files to the hard disk, for example. And then it could be helpful to have multiple threads to write down the files. It could always be 2 or 4 or 8 or 16 and so on. That's also important. And you have to consider that this cannot be changed the easy way. So that means when you set your channel count to 2, for example, you will not be able to change that afterwards. So when you want to change it, you have to create a new storage manager with a second configuration, and then you have to copy the data. It's not that big effort, but you have to know that it's not possible to change that on the fly. So just to change the property, then you will get in trouble. So when you want to change it, then you have to migrate your storage, and that's, as I said, not a big deal. Just create a second storage manager with the new configuration, and then you have to copy the data and store the data again. That is all what you have to do. And yeah, as I said, or to be honest, I use the 2-channel count. It's totally enough. And I think you should try it out. What fits best for you? How many channels fits best for you for your system, and then you can use it in production, or you can use the right amount of channels in production in the end. So just give it a test, and then you know what's best for you. These are the storage channels. And another interesting part is the housekeeping part. And the reason for that is every changed or inserted stuff of the database will be appended to the end of the binary files. And that means, let's say we have this data here. It could look like this. It's just an example. But every time we change something in that string here or in that object, this object with the ID 1, 2, 3, 4, 5, 6 will be appended to the end of the binary files. So, and that means after 4 stores, we have 4 times the same object ID in our storage. And that's the reason why we need those housekeeping processes to clean up the storage from time to time. So, and this is done by the housekeeping. And that is the problem, because when you have quite heavyweight, or when you write data in a very high frequent way, it might be possible then that it's not enough time left to do the housekeeping, and that might the result would be an increasing and increasing data storage in the end. And for that, let's have a look to that later on. So we are able to adjust the interval and the time budget of the housekeeping. That means we could say, let's do the housekeeping. Oh, sorry, I can do the housekeeping every 400 milliseconds and do the housekeeping, or this is the time budget, 100 milliseconds. I prepared a small example for you. You can find this example also in my GitHub repository. Let me share the link to that. MicroStream configuration. Here it is. So this is the project itself. It is called MicroStream Training Configuration. And let's get let's go through this application. There are also multiple branches in it. So we have the configuration done. This is yeah, let's have a look to this configuration done. That could be interesting to you. I created that. Just go to the DB class. That's the important one. I created 4 different storage manager here in that case. And I did this with 4 different in 4 different ways. So the first one is built with an XML file, which is loaded here. I created, or I used a MicroStream.xml file. Could be this one here with the store directory and the channel count. And I set this channel count to 4 in that case. And then I create an embedded storage configuration by loading that file. And as always, first I create a configuration, then I create a foundation, and out of that foundation, I create the embedded storage manager. This is how it works all the time. So this is one example of how to initialize MicroStream. There is another one that is a short initialization. So that means you can also do it like that. Embedded storage start, hand over the root object, and hand over the storage path where the data should be stored on the hard disk. Short possibility. Then this is what we did in our example. In our warm-up example, we used the builder, embedded configuration builder, set storage directory, set backup directory, for example. This is the Miro, the Miro backup. Have you ever used it? That Miro, or some of you might have used this backup. I think it's part of the fundamentals training to know how to create backups with MicroStream, and this is the way to set the Miro of the storage. So whenever you write down your data to the normal storage, it will also will be written to the backup directory. So we can set the channel count, and as always, we create the foundation, set the root, and then we create the storage manager out of that, out of the foundation. And then we have the extended one. And this is quite confusing. This is the example from our documentation, but it's yeah, it's possible to use this in a more detail, in a high detailed version. Here you will be able to adjust everything, I would say. I never used that before, to be honest, but most of the time I use this one, and that should work for you. There are some special things you have to adjust this on the foundation directory. Give me just a second. There is one. Yeah, the housekeeping stuff. I think housekeeping must be set on the foundation. Set. Maybe it's also, we changed that. Just set housekeeping, or housekeeping is also part of the configuration, but there are some configuration which must be configured on the foundation. Nothing important, I guess. So okay, not that important. I think this one is the important one. And this one, yeah, it's also part of our documentation. So if you need that, take it out of the documentation. And yeah, this is the reason for that branch. Let's go to the housekeeping branch. I think that's more important for us. Core exercise. No, this one, configuration, team, switch, housekeeping example, discard the changes, and here we are. Okay, let me explain that that project a little bit to you. We have some mockup data here. That's why we have the mockup utils. Some data will be loaded out of a JSON file, authors and books in that case, and will be stored to this two domain classes, author and books, with an ISBN in it, name, release, price, author, and so on. Then we have one controller, and this is a really special one just to simulate the huge amount of requests. When I call create books, an in-stream starts here from 1 to 10. So that means it loads the books 10 times and stored it to the database. And this is yeah, I would say that is storing data in a really high frequent way. And the special thing is that we have the store on every for each. So let's have a look what happened when we start this one. So let's start the application itself, and let's have a look in the end to the storage. Just to refresh. Okay, no storage at all. Where is it? Yeah, here. Let's run that. Okay, up and running. So let's access the database, and let's say, so I do this on the browser, the book controller, let's say books, and create is the call. So let's say books dot or slash create. Okay, now this one is running. You can see it here. And when we now move to, now we have to be fast. So show in System Explorer. Let's go to the data channels here, and you see here, this is the result. We have a lot of channel files here. And the reason for that is that the housekeeping process was too slow to clean up the storage. And give me just a second. I just want to show you that again. So let's stop the application. We don't need that data anymore. Let's start it again. Create. And now we have to be fast again. Data channel. I can see that. You see that? It increases and decreases all the time. And that's why we have to change the housekeeping process. Okay, now it's done. And as you can see here, yeah, we have to prevent it. And that is all the time when you have if you write down data in a really high frequented way. And for that reason, we have that housekeeping. And I prepared the two properties here. So we have this one. Oh, let's do it like this. We don't need this anymore. So let's set the housekeeping interval to 400 milliseconds and the time budget to 100 milliseconds. And let's see what happened when we create the data with a different configuration. So let's delete this data. We don't need that anymore. Start the application. Okay. Let's do a refresh here. Let's have a look to the data. And now you can see the data stays small because the housekeeping has now much more time to clean up the data during the store processes. And that's the reason why sometimes you have to change the amount of the interval and the time for the housekeeping process. And I would say the channels and also the housekeeping process, it's important to know about about these two different configurations, because sometimes they could be important. Okay, some questions to configurations. I think, yeah, that's the most important things. There are some more configurations, or there are some more possibilities to configure MicroStream, but I think that are the most important ones. So let me just change to another branch within that project. Switch to configurations done. Discard changes. Continue. Just stop the application. Yeah, of course, as I said, there are many more configurations. So set channel count, you will find it here. Set housekeeping interval. You can also define this in this way. Set housekeeping interval with a duration, and also set housekeeping time budget. It's the same within the Java code as to use this in the XML. It's totally the same. Okay, any question to that?
Yeah, can we change the garbage collection setting in one time?
Sorry?
Can we change the setting in one time?
I don't get it right. So it's a bad connection, I think. Can you repeat that, please? Or write it down, so that will also help. Ah, okay. That's a good question. I think that is not I'm afraid that is not possible. You have to set it once. Of course, you can change this, but then you have to restart or to reinitialize the storage manager. But that is a good question. I will check that for you. Let me take a note of that, because I think it's not part of the documentation also. But let me just check. Maybe I can find this. Lifetime. No, it's yeah, I'm afraid you have to restart the storage manager. But as I said, I will take a note, and I will let you know if this can be changed on runtime. changing GC background. Okay, got it. So this was a question by. Okay. Okay, some more questions to the housekeeping. Okay.
Are the possibilities in the XML exactly the same as in this setter here?
Not all, but
Okay.
yeah, mostly yes. But some adjustments or some configurations has to be made in the Java code. Then you will not be able to use the XML file.
Okay. What's the particular reason for it?
Maybe it's the effort of implementation, I think.
Okay.
Yeah, and I would say in most parts it makes more sense to use the Java way to initialize, because then you can use some system properties or some environment variables. I think that makes more sense to use them, and in my opinion, I would recommend to use the Java way to initialize, but yeah, it's totally up to you. And especially for MicroNode or Helidon, there are special integrations for that. It's different in that case.
Okay, thanks.
Okay, but you will, and I think there are some informations regarding that also in our documentation. Give me just a second. Maybe I could find the. Yeah, maybe if there is something important for you, you can find it here. Every property is explained in detail, and maybe you could find some hints there. But as far as I know, especially in the version 5 and 6 of MicroStream, there are some limitations on the XML file. But maybe in version 7 we did all that implementation, but not sure about that. Okay, so let's move on to the next part of the training. It's I have to find my script. I think it was the storage configuration. So let me skip this one. And we don't need this. Okay. So okay, here we are. So let's talk a little bit about the store functions. Also a small topic, but it's important, especially to know how to handle transactions in that case. And there are some functionalities, some built-in functionalities that are important to know. So this, what we can see here, is the basic store functionality we used in the warm-up project, just to call the storage manager and use the store function. And as I said, you always have to store the object which has changed. This is the normal way to store. Whenever you use the store here, in that case, we call it the lazy store. And that means that only the object which has changed will be stored. But sometimes it makes more sense to have an extended store function, and this we call the eager storing. And that means, so as I said, lazy storing stores only the object which has changed, the object which is hand over to that store method, and only that will be stored. And when you use the eager storing mode, then all the changed objects below that object, which is hand over to the method, will be stored too. So that means it stores all modified child objects, and of course at cost of performance. That is why we use, most of the time we use the lazy storing, but in some part it makes sense to create an eager storer and to store all changed child objects in the graph. And this is possible. And how to use that eager storing that's also interesting. Just call the store manager in that case, and then you can say create eager storer. And then you will be able to add the objects to that storer. So in this case, we go through all that books, and in each book we set the price, or we multiply the price. And after that, we append the changed object to this storer. And only when we reached, or when we call store.commit, the objects will be stored to the database itself. And that is the reason, or that is also, or let me say that you can use this as, or you can see that as a transaction. So you will be able to do some try-catch stuff here in between, and to do the store commit, for example, within the try. And whenever it fails, you have to roll back the data in the end. And for that, we jump directly into the project. I created also an example project for you. So there it is. So we need, okay, we don't need this anymore. It's a project which is called exception handling here. Let me copy the URL. Oh, come on. So, exception handling, here it is. So this is the URL to the GitHub repository. And now let's have a look together to that exception handling project. When you check out the project, you can directly switch to the let's say, let's do the rollback impl down. I would say, yeah, let's start on that branch. That saves us a little bit time. And then we can go directly to the controller. And there are some, I implemented the rollback. And there is one special thing, the rollback mechanism isn't implemented yet directly to MicroStream, but there are some, a class in it, which is called binary persistence reloader. And you can use this persistence reloader to roll back data of your RAM. And also, yeah, that is, you can use this, and this class will be integrated in version 8. But if you need it now, you can use this one, and after that, in version 8, you can change this. And in that controller class, of course, we have to create some books, but that is not important. We have to get these books. That's also okay to clear. And here comes the interesting part. So whenever something happened or something went wrong during the the store, or when you change the RAM and then something happened and you have to roll back. And I simulated here that in these two methods, I did that. So update a book and non-store it, and update an author, non-store it. And the reason for that is it's possible to have a rollback, a deep rollback and a normal rollback. And then we have the two methods here, rollback flat and rollback deep. And this is the explanation how to use that binary persistence reloader. And yeah, just have a look here. We have a book object, which is filtered by the ISBN number. We have that book, then we say book get name, and the old name is stored here, okay. Then we say book set name Java the good parts, for example. And here we have the response is name of book successfully changed from this to this. Okay, we have that, and this should be this should be the same. Here we changed the author, so that means we get the book, then we get the author, and then we change the last name of the author. In that case, we changed the last name to John Travolta. Yeah, that is the same. We changed the author. The differences between that and that is here we changed the book directly, and here we changed an child object, or we changed an attribute of a child object of the book. And here in this case, we use the rollback flat. So that means we roll back the book itself. And for that, we get the book again. So this should be the new name. And then we use the binary persistence reloader. We instantiate that by hand over the storage manager, and to be more in detail, the persistence manager. And then we say reload flat. And then we have the book object here, and then we will have the old name again. And this is how it works. And the same handling on the deep rollback. So give it a try. And you can also do that. You have the project, just start the project. It should work directly. Run as Java application. Okay. Maybe we have a browser already here. Okay. Let's say localhost 8080, and then I think it's books. Okay, it's empty at the moment, so let's create some books. Books.create or /create. And now we should have some books in it. Here they are. Let's try to find the book with the right ISBN, or just call the book directly. So rollback flat. So update non-store. Let's do this one. So slash. Okay, the book successfully changed from star chamber to Java the good parts. So that means when let's access the books again. Now you can see here, this is the book where the name has changed, and but we didn't store that. That means you will not notice that in some parts when something goes wrong during changing the RAM and updating the storage, you would not notice that there is something went wrong in that case. And that's the case why we need to implement a rollback in that case. And let's do this. Let's say books, and then we say rollback. Okay. Books /rollback flat. You can see we started Java the good parts to the start chamber. And this is the old value again. And this is how to use the rollback functionality. And as I said, it will be a built-in functionality in version 8. But for now, you have to use that workaround with the binary persistence reloader. And we can do the same with the deep rollback. That this is also possible. Update non-store deep was the update non-store deep. No. Name of author changed. And then let's try to find, yeah, you see here, John Travolta. It's the child object of the book. And now let's say rollback. Rollback deep. And that's it. We have that Roger fix again. Okay, any questions so far to that rollback mechanism? It might change a little bit in the background, but yeah, it will be a built-in method in version 8. And this could be very helpful, but in my experience, it's not necessary to use that rollback stuff all the time, because it's yeah, how to say, it's a very rare situation that something went wrong within that code. In most cases, it's a bug and you have to fix it anyway. So yeah, in some special parts, for example, when you use Kubernetes containers or something else, or you use persistent volumes, and for any reason the volume is disconnected, for example, to the container or something like that, then it went wrong. But yeah, it's a really rare case where something went wrong. But of course, we have to take care about that. But most of the time, we don't use any rollback mechanisms. In this case, we use, when we have those heavyweight errors where the persistent volume is unclaimed, for example, then we tear down the storage manager and throw an exception and stop the application itself, because this error is such a heavyweight error, you shouldn't recover the application. That's how we do this. And for that reason, there is another branch within that project, because as I told you, the exception handling, it's also an important part of MicroStream. There is another branch. There's a team, and it's the exception handling best practice branch. And most of the time we use stuff like this. So when you have a look to the DB class now, we add two special store methods to the DB class. This is just an example. You can do this also in different ways. But whenever we use the store function, we don't use the store function directly from the API. So we create another store function by our own, which is synchronized to ensure that all the store functions itself are synchronized. And but I will come to that later. And inside these, we store and we wrap this within a try catch. And if something went wrong here in it, we threw that error or this exception I think that's the best way to do. And in the end, we say, okay, if something happens really wrong, we shut down the storage manager to prevent losing data in this case. But as I said, most of the time, there are some bugs in the application itself, and you have to fix it anyway. And yeah, it's quite rare, those situations. Anything from your side?
By the way, Christian, how can we recover when the storage is broken in that case? Just recover from backup or something like other solution?
So if I get you wrong, if I get you right, so how to recover the storage itself, right?
Yeah, in that case, when we have thrown an exception and shut down the application.
Okay, there are many different possibilities. So basically, you should always have a backup in place. So there are two backup functionalities which can be used with MicroStream. Give me just a second to show you that. Where is it? Storing data. No, configuration is the right point. Backup. Okay, here we are. Okay, so we have two different backup strategies with MicroStream. There is one, we call it continuous backup. And as I said, it's kind of like a mirror. So whenever you write down data to the normal storage, it will also be mirrored to a second storage folder. And it could also be mirrored to, for example, an AWS S3 bucket. So that's also possible. You store the data directly. The main storage is on your hard disk, for example, or on your persistent volume. And the backup could be an AWS S3. That's totally up to you. This is one possibility. And so when the storage itself is really destroyed, then you have to copy the storage from the backup directly to the storage folder and start the application again. But normally the storage itself. So for example, when you write down data to the storage, and right in this moment, the persistent volume will be unclaimed. Then you have only only the half of the data is written to the persistent volume. Then after a restart of MicroStream, MicroStream will repair the storage itself. So based on the transaction files we have in the background, and MicroStream will automatically check the last write, and if it's written in full or in half, and then MicroStream will delete the last write in this case, so that the storage itself stays consistent. And this is handled by MicroStream itself internally. But when it really happens that the storage is somehow destroyed or something like that, then you have to copy the storage manually. And this could be made by using the continuous backup, or there is another possibility to use that full backup function, because you will not be able to, let's say, to copy the storage 3 times a day to a different system. Basically, it's possible, but you shouldn't do that from outside. You have to use an internal function, because this function has to be part of the queue, I would say. So because you have to ensure that the last write is written full, and then you can do the backup. So that means the full backup should be part of the application queue, or of the to ensure the consistency of the storage itself. So that means you have the continuous backup as a mirror and the full backup. And whenever something went wrong, just copy the backup to your production storage, and that's all you have to do. Is that the information you need or you want?
Thank you, Christian. Okay.
Okay, so some more questions to that. And I would say most of the time when something happens, especially something like this, you will be able to shut down the storage manager, and you will also be able to start the storage manager again. And most of the time that will work, but I would not recommend that because, yeah, as I said, most of the time there are some bugs in the application itself, and you have to fix it first. And yeah, of course, it might happen that the volume, for example, is disconnected from the container, but yeah, that is not, yeah, I would say a normal. That is not normal, I would say. Should not happen that much or that often. Okay, so some more questions to that topics.
While waiting, Christian, I have one question about working with Lambdas and AWS S3 storage. So
Okay.
I was going to put it in the end, but if we have now a few more minutes, I would like to post it in the chat so you may have a look at it.
Okay, sure. There is all. I created also. You will find an example of that in my GitHub repository. I created 2 Micronaut projects specially made for Lambdas, but I did not use the Micronaut integration for that. But these 2 examples are also working within AWS Lambda.
Yeah, cool.
But yeah, let's have a look together.
I put a question in the chat.
Okay. Ah, okay. Okay. Yeah, that's a good question. So basically, each Java virtual machine can only have 1 MicroStream storage because of the file lock stuff and so on. And it is so you have to prevent a parallel. You have to prevent parallel Lambda invocation when you use MicroStream init.
I have tried to do that, but I cannot do it on the free AWS Lambda tier. Or I don't know how, or I cannot. I tried several times, but still with no success.
There is. I've seen an option for that. Give me just a second. I have to.
Okay, please.
Okay, so I have to skip this. AWS Lambda. We can have a look together. So this is the Lambda backend, and there is serial. That is the product service I created. This is the API gateway. So configuration. Somewhere here must be the possibility to prevent just to check. Hmm. Concurrent execution. Here's Lambda. Configuration, concurrency, under concurrency, choose edit. I think that's the right place here. That all that stuff is in German, but this means concurrency. And then you have to click on edit. That should be that. And then choose reserve concurrency and enter the amount of concurrency to reserve for the function. I think you have to do it like this. Just set it to 1. And that means no concurrent invocation of the Lambda.
You know, I have tried that, and
Okay.
I cannot do that because I'll send you a link in the Discord chat. I asked questions there, but still no answer. I have an reserved account concurrency of 10, and I cannot. When I put 1 here, I've got 8 in the nicht reservierte control behind. Yeah, here, and warning that the unreserved account concurrency can go below 10. So.
Okay, where did you get the error message? Inside the JVM, or what is?
Inside the AWS Lambda console when configuring properties for my Lambda function.
Because there is the possibility that that Micronaut itself raises the same REST endpoint several times, so invokes the endpoints multiple times. So that could also be possible.
I am not using Micronaut. I am just playing with plain Java
I see.
embedded storage.
Okay, that's interesting.
Yeah, that is the issue. I am on the free tier, so I was expected to play with it for some time and get some experience, but still no chance.
I have to say, let me check this.
Cool. That was the point. Just raise the question.
Yeah, that's great. Good question. Let me take a note, and I try to answer this later on. Maybe I have to talk with some guys from our company. They already are more in detail with the Lambdas. So
great,
sure they can help. Yeah.
It would be cool. That is my pet project since the MicroStream first training. So I just bounced the wall, and it's already almost 2 weeks. I just get it up.
Okay.
Oh, good. It would be cool if I can resolve that and move further. Okay.
Your name was again? Sorry.
My name is Volodymyr Protsaylo.
Okay, got it. Yeah. Maybe it would be great. Send me just a short reminding by mail. That would be great.
We'll do that. Can I do it right now or after the meeting?
Just send me a short reminding that I knew your email address, and then I can answer directly.
Thank you. I'll do that right now, and you can read it whenever you will have time.
Okay, great.
Great. Thank you. See you.
You're welcome. Okay, good. So all the other guys are back again. What about you? Can we go further?
Sure.
So that means I forgot to show you one small part of code regarding the lazy and eager store, and yeah, you already seen that, but give me just a chance to show this in the project itself. So that is the configuration done. Housekeeping. No, that's the wrong. This one should be the right one. Team switch to. Okay, this is just one example to handle that rollback. We already talked about that, but one implementation of that could look like this. So that means in this case I use the lazy storer. It's but it works the same. So that means we create the storer itself. I called it ls. Then I filter some books. And in this case, I try to get all the books where the ISBN starts with 4 and 9. Just a few books here. And then I change the price of these books here to big decimal 50. And then I say lazy storer store B. And after that, I try to commit that. And if something goes wrong here or in between it, we switch to the catch block. I raise the stack trace, and of course I should use some logging stuff and so on. And here is the part where I use the binary persistence reloader, and then you can roll back the changes of your books. And this is what we done here. B set price reload flat B, is that right? Filter books for each. Yeah, okay. And here is the reload flat. And that's how it works. So one possibility, it might, there are, I'm pretty sure there are 1,000 more possibilities to use that rollback function, but it's just a short example of that. You will also find this in that project. Okay, so we have the configuration, we have the advanced storage parts, some exception handling, rollback stuff, and so on. Now let's go further to the lazy loading part, and this is a quite interesting part for most of our customers. How to handle lazy data. I prepared also an application for that, which is called Lazy Demo. Give me just a second to share the link. Lazy Demo, here it is. The link for you. And this could be also quite interesting for you to check out and run the project on your side. Now we need a lot of windows. So because we want to have a look also to the RAM itself. So and for that reason, I take the JDK monitoring tool. Give me some seconds to open that. C programs, Java. So I use the visual VM, should be totally okay for that, to measure the amount of RAM of my system, that we can see what happened when we use lazy or not. Okay, this project has several branches in it. So and we want to start on the first branch. It's the master branch. Just let's have a look what's inside. So we have some controller classes. We have our DB, which is already here. We have one domain object, which is a person. This person has a UUID, first name, last name, some string fields in it. Value, something like that. Nothing special in the person object. And the controller data root is the important thing or the interesting thing. We have one collection which contains all the persons. And in our controller, we have a create method, and it runs 1 to 20 to 201, and it creates around, oh, I'm not sure, it should create around 600,000 of that person. And let's have a look what happened when we start this this method. So this is going to be interesting. So let's do this application. Run as Java application. I think I have the Postman. Lazy exercise. Person create. That is the. So let's check the Visual VM. So this is the process we have here. This is the MicroStream application. Let's check the monitor. Okay. So find person. Let's raise the let's start the storage manager. Just we try to find one person. Oh, not found, not found. Localhost 8080. Give me just a second to find out what's wrong. Nothing special here. Person controller create. Ah, okay. Get person. Okay. Postman is here. Ah, okay. So persons. That this should be the. Oh, this is the persons. Okay. Ah, I know why. Okay, some errors in the code. The reason is there is still a data in place. So whenever you start the application itself, please have a look to the folder, and if there is already a data folder in it, maybe I accidentally committed it to the Git repository. You have to delete it. So that's important. So let's check Java application. Because the structure of the storage changes from branch to branch, and that's why the storage of branch 1 wouldn't run with the storage or wouldn't run with the configuration of the branch 4, and that's the reason why it isn't working. So okay, now let's give it a try. So I have it here. Find person create, find person. Let's try this one again. Oh, let's get this one. This is quite hard to handle that on one screen. So let's try if this will work. Okay, so that is the application itself. Monitor. We only need the memory here. That's the important thing. And let's start. Okay, that is the startup of the storage manager itself. So there is no data in it. And now let's create the data. Let's call the method create persons. And let's see what happens when we call this. Okay, set. Okay, it creates 200,000 person now. And for these persons, we need around, yeah, let's say 800 megabytes, I would say. 800 or, yeah, around, let's say the base stuff was, yeah, 100, 150. So, yeah, around 1 gigabyte for that 200,000 persons. And I don't know. We have to take care about that. Maybe there are some more, and it depends a little bit on how many RAM we need. And I have to say, so basically, it's up to you to decide which data should stay in the memory and which one should stay on the hard disk. But in my mind, I would say the data which is the most important one, and if I need the data all the time, then it makes sense to keep it in the RAM, because you have to deal with that data on the application server side anyway. So that means you don't have to load it from the database, and even the data is not in memory and must be loaded from the database side. You have to process the data also in your application, and that's why it makes no differences to have in-memory data in the application or to load data from lazily and then to process the data through the application server. It's mostly the same. But what if you don't want this data all the time in memory? So maybe let's say this is some archive data or some data which is not needed all the time, and we have to take care about that these data stays on the hard disk. Then we have to change our data structure. We have to use lazy instead of using a normal list in this case. And for that reason, I can change the branch. Let's have a look to the first solution. I will delete the storage again. Okay. And now let's have a look to the next branch. So let's say step 1, let's change it to lazy. Now it looks like this. So lazy is working like a lazy wrapper. That means we still have that list of persons in it, but it's wrapped in a lazy object, and that means the data stays on the hard disk as long as it's loaded, and after loading the data, it stays in the RAM as long as MicroStream recognizes that some capacity is missing, or some RAM is missing, and then MicroStream clears the lazy references to prevent the application from shutting down because of out of memory error. So, and let's see what happens there. Let's start this application again. Okay. So we have it here. Let's enable the monitoring. And let's choose the create button. And yeah, the result is the same, I would say, because the data is inserted to the database. And yeah, as I said, the result stays the same. In some cases, the result, it's a little bit higher because the lazy references we need, they need some space inside the RAM. And now the data is loaded. But the difference is when we now stop the application and start it again, the data stays on the hard disk. So when we now just try to wake up the application itself, or the database itself, can I check where's the controller class? Do we have an init? So as you see here, I just want to wake up the database without getting or calling some data. So I use that init method. Where is it? Here we have. So I have to do this on the browser side. So, but that's best for you. So I will use that localhost 8080 on my second screen. So, and say person.init or /init. So. That is not that what should happen. So did I miss something? But I think, yeah, it's working. So, yes, because you can see it here. So normally the size of the data should be 1 gigabyte or 1.5 gigabytes around that. And this is the result by using it with together with lazy loading. So in the end, you will have around 200 megabytes and the data stays on the hard disk. But does this make sense in your application? What do you think? Makes that sense, or are there any problems on that solution? Is that a good solution? What do you think? It works. Okay, the data stays on the hard disk. That's what we want. But what happened when we try to stream or to get some data out of the persons? We have to load the whole list in worst case. So in the worst case scenario, when we stream during the list, we have to load all the data. But in this case, we have to load the whole list. So that means whenever we stream or filter through the persons, we have to list the whole, or we have to load the whole person list again. And in my opinion, that makes no sense. So that means, okay, basically it worked because lazy list, but that is not the best solution. But let's try this. Let's load the persons just to see, or let's try to find a person. I have to check the person controller, create, get persons. I don't have that, right? So I have the person IDs. Should be this one. Let's call it. And in the end, we will see that the storage increases again in that case. Yeah, and you can see now you have the persons and we have the same amount of data in the RAM as normal. Of course, the benefits of that is that if the RAM is needed by other operations or by other data, MicroStream will skip the data. But yeah, that makes no sense, because if we have multiple concurrent users on that and all that users accesses to the data, you will need, or you will have data all the time in the RAM. And then, yeah, in this case, lazy loading does not make any sense. So we have to find another solution, a better one. And for that reason, let's change to the next branch. So I clear the data again. And let's switch to a map. So that is the new root object. And now we have a map. And this map contains a lot of entries. And it's a string. And on the other side, it's a person object, which is wrapped within a lazy object. And yeah, let's see how many memory we need for that example. So that means let's click on that. Let's start the application. A lot of windows I have to deal with. So here we are. start the application. So I use the init operation now to wake up the storage. Oh, first we have to open the application itself. Let's see it on the monitor. So, okay, say init. Okay, that is the basic initialization of the storage. And now we have to use another get person. Yeah, I think that's the. We used it get person again, and there are no persons inside, so I have to create the persons first. Okay, here they are. Let's perform garbage collection and okay, the person are still now in the RAM. And now let's see if there are some differences. I think the most the biggest difference between the list and the map solution here is, what do you think? What are the biggest advantage of this solution here? What are the advantages here? Are there any advantages regarding to the related to the list of persons?
We can quickly search through the list via filtering it with the stream functionality, Java streams.
So the only advantage, in my opinion, is that we are able to search within the key, and we don't have to load the person object itself. So, and then we are able to reference the person directly via the key, and that's I think, yeah. And also the amount of references within the map is also a problem. So we have to find another solution for that, a better one. And especially also the lazy reference, it needs also amount of RAM. And in some parts, the lazy reference are more, or the person sometimes is cheaper than the lazy reference itself. So that means you should use this only when you handle some stuff like binary data or block or binary objects or something like that. Then that could be helpful. For example, you have a huge amount of images, for example, and then you have the image wrapped by a lazy object, and you have a description of the image or an ID or something like that within the map. That could be possible. Then this solution would be a good solution, I would say. But in my opinion, there is another solution, and for that I will switch directly to the last branch. This could be, I think, the best solution, especially for the best practice, or you would use, but let's talk about that. Let's switch to branch 4. And in that, I use a persons container. I call it persons container. And so that means I have persons as an object, and then I have persons, a persons container. And within that container, I have different maps. And for example, I have persons by last name in this case. And to be more detailed, I added only the first 2 digits of the last name as key to the map. And for that reason, and with that solution, I created multiple smaller lists of persons. that could be a great solution for your object model. And another advantage is that it makes no differences to have multiple maps, because the references are all the same. So it does not double the amount of RAM you need, because all these stuff are all references, and that's quite easy to handle, I would say. Of course, one reference needs also RAM. That's for sure. But this could be a great solution, especially to handle a huge amount of data. So, and I did that in all the parts. So the first digits of the last name, first 2 digits of the mail, for example. But this is totally up to you which index you choose for your map. And then you can have a lazy list of person. And yeah, that's great, because you don't have to load the whole database at once. And yeah, to be honest, it makes no sense to load a list of persons, for example, or to load a list of all persons in a grid or in a table or something like that, when you have that huge amount of data. So let's check it out. How does it work with that solution, and how fast it is? It works really great. There is also an example in that bookstore demo on the MicroStream GitHub repository. It's the same solution. Give me just I use CQ instead of using multimap as indexes. Okay, sounds great. I will have a look at this. But give me a second, I have to start that first. So delete the data. Okay. Start it. It's quite confusing, such amount of different windows and Postman and this stuff here, monitoring. And okay. Oh, I have to check the controller first. We have to create. Then we have a new a last name. And we have the init again. Okay, let's call the create. Here we are. Create. Send. Let's have a look to that monitor. Okay, I'm totally fine with that. I have to check if there is the lazy cleaner already in place. Just a second. I will come to that later. Okay, so as you can see here, I created a special lazy checker, and it checks all the time if there are some lazy instances loaded, and it clears the lazy instances automatically after 1 minute. This is one possibility to ensure that all the lazy instances stays or will be cleared out of the RAM. And that is one possibility. And because of that, when I perform a garbage collection here, you will see MicroStream goes down, and it will all the lazy references will be cleared out of the RAM. And now when we want to access some data, let's try to find a person, for example. For example, the person with the last name Koch that sent the request. And you see, we get a lot of persons here. But the amount of loaded data stays quite low. And I think that's a great solution, especially for handling big data within a MicroStream database. It's a great performance to handle that. But I think the biggest advantage of that is that you have the possibility to to create an object graph, or you have to create a data model which fits to your application itself. You don't have to create a data model which fits to your database. You should create a data model which fits to your application itself. And I think that makes more sense. And especially when you use Hibernate and something like that, you have also deal with mapping to the relational database. And yeah, that's in many times that's quite a mess to handle that. So I think that is also not the easiest part to create a good data structure, but it makes more sense to do that related to the application itself. Okay, any questions to that? We can do another search. And that's, let's say, I don't know, let's say BA. Is there anyone? No. Try to find a person's name. These are, yeah, let's try to find this guy. Have a look. Yeah, you see the amount of RAM we need is quite low, and every time we perform a garbage collection, you will see the RAM will stay as low as it can be. One question from my side: does this make sense? In case of data, when the data should stay on the hard disk, that's okay. I'm totally fine with that. But what about to handle data in general like this? Does that make sense? For data which is needed all the time?
Yeah.
I think maybe not, because you have to load.
If the references change too often, you mean, or?
Not like the reference. The references are still the same, but because that's all the same, it's the same object in the end. Or one moment, is it different? It's different. Yes, the object ID changes in the background. You're right, but that is not the point. I think when you have multiple users on your application, multiple concurrent users, you have to deal with that data anyway. And because Micronaut have to transfer the data, for example, or your application have to show the data within the UI or something like that, because that means the data has to be in the RAM anyway. So then it makes no sense to let the data stay on the hard disk. In some cases, especially for that data which is often used, it should stay in the RAM. It makes more sense, especially with MicroStream, because all the concurrent users are working on one RAM, I would say, on one object model. Of course, you have to deal with concurrency and you have to prevent concurrency accesses, but in the end, it makes more sense. For example, when you have an Hibernate application, then you have to use the Hibernate cache, and each concurrent user queries its own data, right? So every concurrent user has its own data instances on the application side, and that could also be a problem, and that's the reason why you use caches in the end with Hibernate, for example. And it's the same. It's the same on for example when you use Elasticsearch, for example. You need the data in memory because you need the performance, then the data has to stay in the memory. That means whenever you have data which is needed all the time, don't keep it in the memory. And just for data which is not needed all the time, that data can be or can stay on the hard disk. But yeah, it's up to you. You have to find the right solution for the right object graph for your application, I would say. And then you can handle a lot of data also with MicroStream. Okay, any question to that? I think that's a good solution. I'm pretty sure there are many more or some better solution than mine to use those lazy references. But I think the basic approach of lazy is yeah. Any question to that? How to use that lazy stuff? Because some of our customers ask, especially for the get methods, for example, should I unwrap the person directly within the get method here, for example, or should it stay in the lazy? I would recommend to leave it within the lazy reference, and in the end you can say get, because every time to unwrap the person is you shouldn't do that. That is quite an overkill, especially to handle that with REST interfaces. Leave it in the lazy wrapper. It's I would recommend that. Okay, there is another thing I want to show you. We have already seen this, the lazy reference manager. There is also a solution that can be used manually. You can call this by yourself. We can have a look there. So, it's on a different branch. Just a second. It's on the stage 3 branch. To say switch to change to map. No, on the other one. To switch to change to this. Yeah, here we have it. So you will also be able to use the lazy manually, and you can use this call lazy.clear. Especially for situations where you want to upload or insert a huge amount of data, and you don't want that these data stays in the RAM after uploading, for example, then you can use the lazy clear manually after uploading, like me here inside the create person method. But it's also possible to use this solution. But I'm not sure if that makes that sense, because clearing the lazy references every minute in some parts, that makes no sense, because you need the data maybe often, and many people, concurrent people will access the data, then you shouldn't clear that all the time. And there is a default handling. By default, MicroStream handles the lazy references. Just a second. There is an explanation to that in the documentation. So storage, lazy, store target, no, storing data, lazy and eager storing. Here we are. Everything I showed you is, you will find it also here. You will find it here, and then eager lazy storing. Give me just a second. I have to. That is loading data. Lazy loading. Here it is. Okay. These are the same examples like I have in my project. Some side notes, and then clearing lazy references. That is the default stuff. So when you don't have that, the lazy reference manager will kill all references within 15 minutes. That is the default. And there is a functionality in place that counts the last touched timestamp of an object to keep it in the RAM. So there is also the possibility to use this. And you should not forget there is also a memory quota. So that means when the memory quota reaches 75% of the memory, then the garbage collection will kill all or will clear the references also. So that's also a configuration part. You have to check how many data do you have in your application, how many data you will keep in the RAM, and how many should be stay on the memory. And especially you have to check how many concurrent user you have, and then you will see, okay, how good does it fits with the RAM of the server and so on. And then you can do some fine adjustments, I would say, to decide when to clear the references and on which memory quota and so on. Okay, any questions? So during that, I would check the GitHub repository of okay, Suro. I need more time to study that. That is too many information. But thank you for the link to your repository. Oh, okay, sounds great. Yeah. Okay, any question from your side to lazy loading? And as I said, we have that collection, that lazy collection, which will be available in version 8, and maybe that solves some other problems. Especially, you don't have to use those maps again. Then you can use collections or a normal collection again. But yeah, it's up to you to create your object graph. Okay, so if there are no questions, let's go further to, in my opinion, to the last important topic for today. It's the concurrency handling, and to be honest, that is not a special MicroStream topic. It's a topic for everyone, I would say. Let me open my presentation first. Okay, here we are. Concurrency handling. That is the first important question. Do we need to take care about concurrencies with MySQL and MicroStream? What are the differences? And why we don't need to take care about concurrencies with MySQL? I think we have to clarify that. Why is it important to handle concurrencies, especially with MicroStream? Possible steps. I will show you some possible steps to handle concurrencies. There are some I would say some mechanisms already implemented into Java, especially immutability, the final keyword, for example. You have to choose a proper architecture or a proper data model. That's up to you. We have some locking mechanisms to use, for example, synchronized, and we have some concurrent collections, but let's have a look to that later on. So for example, concurrency with MySQL. Why don't we have to take care about concurrency with MySQL? So mostly we have one application server in the middle, or and we have some maybe browser clients at the end, some concurrent users, and they access to the application server. And every client which connects to the application server has its own session. That's for sure. So that means we have no concurrency here because the data stays in the session. And it's the same on the database side. We have one single thread to access the database, and that is a transaction queue. And this is handled by Hibernate or the database itself. And because of that, yeah, it's quite easy to use. We don't have any concurrency issues here. There are some special things when you cache data on your own, for example, then you have to deal with concurrency for sure, but not with the normal standard access. So let's have a look to MicroStream. Let's imagine that we use MicroStream as an embedded storage. Then we have a lot of different clients, and I would say this is yeah, it could be a web application like Vardin, for example. Yeah, that is the classic model. And the problem is that all of the clients have a session on the application server side. That's for sure. But all these clients are working on the same object graph, and that's the problem. And for that reason, we have to take care about concurrency. That could be one architecture, and there is another one like this. And I would say this could be also the Lambda solution. So we have a storage server. This is the Lambda part, and this Lambda provides the data to, yeah, let's say to an application server or directly to the client. I think that's the same, but in the end we have a lot of different clients which accesses the endpoints, and as I said, on the Micronaut side, Micronaut duplicates the endpoints automatically, and that's why you have to deal with concurrent accesses. Okay, how to do that? Or basically, internally, MicroStream is single-threaded and blocking, basically. So that means the internal stuff of MicroStream is queued, and everything is working great within MicroStream internally. But on your database or on your object graph side, you have to take care by yourself. And yeah, I would say basically every developer should be aware of concurrency. That is for sure. But there are many different homepages on the internet that explain how to handle concurrencies, but all of them are talking or say this: the best thing to handle concurrencies is to prevent concurrent accesses to collections, for example, or to objects. And for that, you should always use objects that are, and you have to define that as final. That is the first and one important thing. Whenever you can, use final objects. And if this is not possible, then you should try to change the basic architecture of your object model. That could help, and that might help a lot in some points. And or maybe change, if this is possible, change the application architecture, if it's possible. Then you can use the synchronized keyword, but of course that will synchronize all the accesses, all the read and all the write accesses, and that is not the best way to do it. It creates, I would say, a bottleneck in the end. But yeah, it could be used on methods and also on collections. There are some synchronized collections in place, but yeah, sometimes it's not the best solution. there are a lot of different concurrent collections in place. We have, for example, the concurrent hash map. I want to get really in detail to that stuff. We have the copy on write array list, for example. It's a thread safe variant of the array list. It will work, but it's not made for huge amount of data. Just for small amount of data, you can use this one. And yeah, it's not the best performance in the end, I would say. It's the best thing, in my opinion, is this one. I don't know if you ever heard of that, the reentrant lock or reentrant read-write lock. And it's a little bit the same like the synchronized stuff, but it divides the read and the write accesses, and that's a big advantage, in my opinion. Synchronize locks every operation in contrast of if it's a read or write. It differs between read and write locks. The synchronized keyword itself, it's tied to the block structure. That means you are not able to release a lock until you leave the code block. And this is also different in the reentry. You can decide by yourself when to release a lock. That's also, and another big advantage is that the reentrant lock has a fair mode, and that means there is a strict order, like first in, first out, and which is also different with the synchronized keyword. So that means, yeah, first in, first out can be much more efficient in that case. Okay, let's have a look to the project. There are many more information. I want to get more in detail with that. Let's have a look to a project I create. I created one, which is, let me just check, legacy type mappings, storing. Where is my concurrency project? Custom class loader. Just a second. Concurrency. Huh. Okay. So I have to check out the project. I don't know why. Ah, here it is. Okay. Import project. Ah, here it is. Okay, and for you, the link. As always, that you can have a look to the code on your own in your own IDE. Okay, let's see. Let's check which branch we have here. Concurrency. Switch to master branch. Switch to others. Remote. Okay, there are many different branches here in that project. Also, the same steps like in like with the lazy loading, you can try it out whatever you want. I used the concurrent hash map. I used the copy on write array list and so on. Everything is working great, but I think the most interesting one is the read-write lock here, the reentrant read-write lock. And let's step into this one. Let's check this out. Okay, I think the important thing for you is the part within this package here. This is a class we write for you just to use it. So that means just copy these 3 classes here and copy it to your project. you will be able to check that for sure. And then the only thing you have to do is, when we have a look to the book controller, for example, oh no, we have to go to the books. Yeah. So as you can see here, we have the same structure with a map and so on. And I try to find, is that, oh, here is it isn't used here. Ah, but it's okay. So I think that's the branch where we can reproduce the problem itself. So we have the delete random here, and we have the run through. Okay, let's start it. Let's see what happened when we have some concurrent issues. So let's go to the application itself. Let's run this. There's my Postman training. That's right here. Transaction rollback, lazy. That books, is that create books? No. It's Lucene. Okay, doesn't matter. We use the browser. It's easier. So let's say localhost 8080, and then run through the should be through the books, right? So iterate. Books, iterate. Something is wrong. Ah, okay. Maybe there are no books in place, so that's why. So let's create some. Create. Ah, it was still running, right? So that was the problem. Just a second. I have to find the right branch to show you that. Ah, okay, already here. So okay, book clear, create, iterate. Okay. Delete the data and start it again. Okay, just to show you, here are all the books I created. And now let's try to iterate all the time through the books. So just to simulate a lot of concurrent accesses. So iterate. And now you see the application iterates all the time through all the books in the background. And when we now try to delete a book, books, and I think delete book, then we get this type of exception. And this is the moment. Where is the right one? Concurrent modification exception. Yeah, here we have it. And this, we have to prevent this exception. So that means whenever we go, whenever we read over or iterate a collection, and then we delete one element of that collection, we will get this exception. And we have to prevent that. And the one possible solution is to use that reentrant lock. And now we can switch to that branch and say remote branch should be this one. Check out. Okay. So let's have a look to books, where the reentrant read-write lock class is used. So we have that books, and what you see here is, okay, as I said, just copy these three classes, and then you can say, okay, let's create a class books, and this class extends from read-write locked. And after that, we have the possibility to say, okay, whenever it's, let's say, add, for example, this is the add method, and then we can say this point write, and because of that, the framework knows, okay, it's a write request, so it has to be locked. And then we have this is the interesting part. So, and all the other stuff, the read access that is not necessary to lock that. So it's only important to lock the write accesses. And this is a quite easy solution, I would say, better than synchronized, and can be used with a ready class like this to handle those concurrency issues. And we can do that in the same way like before. So let me just delete the data, and let's do the same things again. Start the application. So books/create, and then we say iterate. Okay, and now we can try to delete a book. And now, as you can see, we won't get any concurrency modification or concurrent modification exception anymore. This is working really great. And also the performance, I would say this is the best performance you can get after handling some concurrencies. But as many other homepages said, try to prevent concurrent accesses as often as possible. And if it's not possible, I would recommend that read-write locked in the end. Okay, any questions so far?
Great solution.
Sorry?
Great solution. Great solution.
Yeah. And you can have a look by yourself. Just check the repository, and yeah, this is working really great. Better than all the other concurrent collection which are part of the JDK, for example. They are also great, but not for a huge amount of data. Okay, so why is that so important? Yeah, as I said, normally you wouldn't need, or you would not have to deal with such amount of concurrency stuff, but especially with MicroStream you have to, and that's why the concurrency part is part of the advanced training, because it's important to know that, and yeah, that's why we have to deal with it. Okay, if there are any questions, so feel free to ask, and otherwise I would say let's do a short break again, and then we can do the last two topics for today, I would say, and then we are finished. So I will wait a few minutes for your questions, and then I would say let's do a short break. You can see my system time. Okay, to clear this. Okay, yeah, it's around 9. I will wait until 9. So for your questions. Maybe we should have a short look to the topics again. Okay, here are the topics. Okay, we did that warm-up project exercise. Then we talked a little bit about channels and housekeeping. We did that. Then we talked about eager and lazy storing, some transaction things and rollback stuff, exception handling. Then we had those lazy loading stuff and best practices. And now we are here. We talked about concurrency, proper object model for concurrency. Maybe there is another thing you have to know when you use those maps, like we did with the lazy strategy and so on. This also prevents, or that also minimized the concurrent accesses to the different collections, you know. So when you have one big collection and many concurrent users, all of the user will operate on one collection. When you split up these collections within maps and have those separations, especially for lazy stuff, you will have also the advantages on the concurrency side. So the possibility that you have that those concurrency exceptions is much lower than. That will also help in the end. It reduces the amount of concurrent accesses, I would say. Okay, so we have to talk about lazy type mapping or legacy type mapping and how it is handled in MicroStream. And then we have some smaller topics, and I think that these topics are only interesting for if you need them, especially when you want to change the class loader and something like that. When you want to use MicroStream within, for example, a special application server like JBoss or something like that, then you have to deal with different class loaders. This is just some small topics. Yeah, and I think that's it then for today. Let's hurry up to the last two topics. Normally, legacy type mapping is part of the fundamentals training, but I think for some of you, it might be interesting to know how it works, or especially to know what happened if the data changes, or especially the data definition changes. In our case, it's the classes itself. So let's talk about this a little bit. So let's clarify those questions. How does MicroStream handle data types? What happens if we do some changes on the entities or in the entities? What changes can be handled automatically by MicroStream? I think that's the most interesting questions in this part. There are some explanation, and this is quite a huge topic, and it's also quite complicated to understand. But yeah, let's try to keep it simple and talk a little bit about that. So basically, when we use MicroStream, we have two different parts in the storage itself. There is the channel folder, but you might have seen the persistence type dictionary file. And this persistence type dictionary contains, for every object, it contains one object definition. This is the blue part here. You can see here. And for example, this is one customer object. This is an entity which contains multiple fields. For example, an ID, last name, first name, male, and gender. And you can see here, this is the reference to the object itself. So, and this is important because there is one thing you should never do is to add some third-party objects to the MicroStream storage, because if they changes during the time, maybe they change the path, for example, then you will get in trouble. Then you have to do a migration for that, and that could be, yeah, that could be quite a mess. But basically, this is the only thing you shouldn't do. Don't add any third-party stuff to MicroStream. But especially the JDK stuff and something like that, that is all handled by us. So we take care about that, especially when we move MicroStream to the different JDKs, and we will provide also, yeah, I want to say we provide special support that all these different, especially we have some data types which are only available in JDK 8, for example, and then we have to deal with that. But this is covered by us. So, okay, that means we, for every object or for every entity in our object graph, we have a registry like that. And yeah, which is stored kind of like this in the end. It's not exactly the same, but it's a little bit like that. We have a type ID and an object ID. The type ID is this one. This is the type ID. And we have an object ID, which is part of the binary again. And the type defines the type, and the object is the object identifier. Yeah, there is one important thing, and it's in that tense here. If there is an existing block in the binary data in the storage, e.g. the type like this, type 100010066, and this type is not part of the dictionary. So let's imagine we delete that, and we are able to do that. Then the storage will not start. And that is, I would say, this is the worst case scenario. Normally that would not happen, basically, but when you touch the persistent type dictionary and you delete some of those objects, the binary stuff couldn't be, let's say, parsed anymore. So, and that's a huge problem, and we have to take care about. But that's why take care about your persistent type dictionary. That's an important file, and sometimes it's dangerous to change something inside that. Okay, what data types are supported? Basically, you will find a list on our documentation. But now let's add an attribute to a customer. And this is what happened in the end. Behind the scenes, we have kind of like a versioning in place. And that means when you add an attribute to a customer, then you have the old one, the old customer type, and you have the new customer type. The first idea when we created MicroStream was, okay, on startup, let's search for all the old customers in the storage and change them to the new customers. But you can imagine that, let's say we have tons of gigabytes or terabytes in the storage, then it would be quite heavyweight to go through all the data and change it. So, and that's why we created that versioning. So that means whenever you touch an old object, it will be automatically transferred to the new version of the customer, but only if it's touched and only if it's stored in the end. So that means when you read the object, you will get the old one, but when you add or when you change the object, or when you add a new value to some of the fields, and then you say store, these objects will automatically transfer to the newest version of the customer. And this is basically how it works. That is the versioning. And now let's talk a little bit how to handle this inside the code. Which changes can be handled automatically. So I would say, or I would recommend, whenever you start to develop with MicroStream, don't do any manual mapping stuff. There is an opportunity to create manual mappings. So let's say this is the old customer, or this is the field first name. Please transfer this field to the first name, especially here. The first name is on the second place here in the class. And now the name was deleted, and then the first name has to be transferred to the first place in the class. And for that, normally you would do a manual mapping to ensure that any migration works best, I would say. But especially during the development, the best thing I would recommend is create a proper mockup strategy and delete your storage. Simplify, delete the storage, and create a storage on startup again with the new structure. And this will work until you start to release the product in production. So, and after that, then you will be able to start, or then you can start to use a manual mapping, or you just migrate the storage. And how could this work? So that means there is a heuristic, and this works in the most, I think, in the most way it works totally great. So, but there are some special things you have to know about that. So especially removed, reordered, or altered, that will be handled automatically. And we will have a look on that. You will see this stuff when you start your storage. But let's get a little bit more in detail later on to that. Okay, let's try this. So I also prepared a project again. It's the legacy type mapping. I will also provide the link again to you. A legacy type mapping. Here it is. This is the link. Okay, and there is I'm on the master branch at the moment, and I just have a simple class, an author class with a male, first name and last name. And yeah, the application is really straightforward, nothing special in it. We have just one or two REST endpoints here, and this is the DB. This is really straightforward. So let's start the application just to create some data in it. So let's say here, run as Java application. Application is up and running. Let's create some books or some authors in this case. So let's say authors create. You can see here, MicroStream starts and creates some authors. Let's have a look to the list. Okay, there is only one author now in the database, which has a male, a first name, and a last name. Okay, so now let's close the application and let's move. So you can see here the storage is in place. This is the data. We have multiple channels in this case. Let's have a closer look to the hard disk. Here we have data, and we have the channels here, and this is the persistence type dictionary I told you. And here you can see these are the most basic JDK data types, but in the end you will find the author class, and here is it. This is the author class with the male, first name, last name, and it has the type ID. What is that? 1 million, right? 1,000,069. Okay, so let's close this. I don't need that anymore. Okay, let's change the branch. And team switch to changes stage 1. Okay, let's have a look to the author class. So now you can see the changes. So that means we have the name of the author change. Now the name is male author instead of male. And we changed the name of the last name to name. And now let's have a look what happened when we start the application again. Application. Moment, I have to disable. I have to disable this first. No, this one just, yeah. Okay, let's start it. So MicroStream recognizes automatically that there are some changes within the class. So let's call the authors again. And on startup, MicroStream knows, okay, there is something strange going on. Something has changed in the classes. You can see that here. I tried to get it on full screen. So you see that here. Okay, we have the current type author. And there is, it creates automatically a second one. And here it is the heuristic, which is working in the background. And it says, okay, we have Java string one domain author mail field here. And this is the value which indicates how obvious it is that it is the same value as the mail author. So let's say we have 70%. Then we have first name. You can see the 100% because it's equals on the same side. And we have last name and name. And you can define this this threshold by your own. So and that's how it basically works. But now the changes are okay, and you can say, okay, that's fine for me. I want to have it like this. But there is another possibility. You can add. What I did is maybe I did a mistake now, but you will be able to add this part, and then MicroStream forces you to confirm these changes. Let's try it again. So let's start the application again. Let's try to load the authors here. Now, MicroStream enforces you to accept these mappings, and then the mapping will be done by MicroStream automatically. So write yes to accept the mapping. Let's do this. And then the data will automatically be transferred. That means whenever you touch the author again, and you can see that here, now you can see it has changed from male to male author and last name to name. And this is working really great. And most of the time, don't care about any changes. It will be managed by MicroStream at all. But there are some changes which are difficult to handle. For example, what happens when we have some data type changes from string, for example, to double, or from double to integer, or integer to double, or something like that. It's the same question like with all the other databases. What do you have to do when a data type changes from string to double, for example? Then you have to do some migration stuff. And in that case, I would recommend to do it like this. Just create, for example, if let's say we want to have a double out of name. That makes no sense, but it's just, let's do that. Then just create another field. Let's call it double in this case, and name 2. Then start the application. Try to implement some business logic to transfer the data from name to name 2. And then within that business logic, you have the possibility to decide which is the migration, what is the migration business logic. And then after the migration is done, you have to store all the objects. Then you can delete this value, and that's it. I think that's the best way to deal with some migration stuff like that. But there is another solution this, you should do this whenever you have those heavyweight changes in your database. But what if you want to create some explicit mapping? For example, let me revert this. So, okay, I will delete the data and then I change to basic. Or let's stay here and let's say start the application and create the author. Okay, authors/create. Okay, so we have here, this is the same result. We have a new storage. And now let's say we have some more changes to do. For example, in the next branch, switch to, or let's stop it and then say switch to changes stage 2. And here we have a special mechanism implemented. And this is one example where also the foundation is needed. As you can see here, in this case, I did not I used the XML part, but on the foundation, I'm always able to add some more refactoring providers. And this is why I said it's not everything is possible within the XML file. Sometimes you have to deal with both at the same time. Just load the basic configurations from the XML and then add some more configuration to the foundation. That's also possible. And in this case, we added a special refactoring mapping provider. And this consists of a special file, which is called refactoring CSV in this case. And this is the file. And within this file, you can decide, or you're able to decide which field should be migrated to another, to the new field, for example. So imagine we had a field which is named, give me just a second, which is named not the controller, the domain class. So that is the new one. What was the name? Mail author, was it right? So mail author, so which is named mail author. This is the old one. And then it should be migrated to mail 6. Instead, when you don't use this, mail author would be migrated to this mail 2. But if you don't want this, you can use the explicit mapping with that refactoring CSV. And let's check the result. So when we now start the application, run as, here we are. So run as Java application. And I knew it. So, okay, something went wrong here. Mail author was migrated to mail 2, but this is not how it should be. Let's try this again. Maybe there is a small issue already in it. I have. Okay, did I do something wrong? Manufacturing CSV open with text editor. Oh, this is not the right. It should be mail author. Yes. Now it's working like expected. So now you can see mail author is mapped to mail 6. And you can see the result in the end. Here you can see now it's part of mail 6. So yeah, it's a huge topic, but most of the time it works, yeah, quite silent, I would say. There are no issues with that most of the time. To be honest, sometimes when project grows more and more, and we have those projects at the moment, there are 5 years and 6 years, sometimes it's necessary to do some more migration stuff, something like that. But yeah, that's the same on every database, I would say, not only on MicroStream. But this is working really great. But I would recommend not to use these refactoring stuff during the development. Just take care about a proper mock-up strategy. And whenever your data change, just delete the storage and create a new one that works best, especially for development. I would recommend. Okay, any questions to that? We could also have a short look to the data again, if you want. So say just show in. Maybe the persistent type dictionary is also interesting. Now you can see here, this was the first author with the mail author, and then we have the second one, which has the different mail fields here. Yeah, just an example. Makes no sense mostly, but okay, some questions to legacy type mapping. Let's jump back to the presentation. Maybe there is something I missed. We already talked about that. Best practice, as I said, during the development, we are able to delete the storage, take care about some mockup classes. This could be important. Changes of multiple attributes in one class should be done step by step. I would also recommend that don't do all at once. It will work for sure, but in some cases it could be difficult. That is, of course, I think that's quite normal. Whenever you do a migration or whenever you change something on your database, just create a backup of that. I think that's quite normal. And this is also, I talked about data type changes require special migration logic in most cases and can't be done automatically. So as I said, create a new attribute, start the application, transfer the data from the old to the new attribute, and shut down and remove the old attribute. That's it. So let's go to the last topic. Are you still there? I'm not sure about that.
Yeah.
Okay. Great. Okay, legacy type mapping. Okay, as I said, the last topics are some not that important topics, but it might be helpful to know that customization. Yeah, that is the right presentation. Okay, the last topic consists of three different topics, I would say. There are very, very powerful functions behind the scenes regarding that customization. And the first one is the custom class loader. This is, I would say, this is really straightforward and nothing special, but you have to know this. The custom storing behavior, it's interesting to know that, but I never used it by myself. So, but it's also nice to know that there is something like that behind the scenes. But this one is in fact a really powerful thing. That means we are able to transfer some data types to a different form, I would say. And that makes sense in some cases. But let's talk first about the custom class loader. Maybe some parent frameworks use different class loader. For example, Spring Boot uses this class loader, and some application server uses different class loaders like Whitefly, for example. And whenever you use MicroStream within those frameworks, you have to change, or you have to use the class loader, or you have to define the class loader you want to use with MicroStream. And for that reason, there is also there are, for every customization, I created a GitHub project. Check this. Custom class loader. It's like this. And I only create a main method here just to show how to add the class loader. So we have the embedded storage foundation, and on that foundation, on connection foundation, you can set a class loader provider. And for example, we have different tenants, and then we can use different class loaders because in some points you start the application on your local machine, then you will need a different class loader. Then you start the application on the production machine, then you will need a different one. And this is how you can enforce the different class loaders for the different environments. Yeah, it's just an example. Just take it if you need. So nothing more to say about that. In some parts, that could be interesting for you. Custom class loader. Yeah. Okay. That is the same. We already have seen this. Custom storing behavior. When to use? Sometimes some data types shouldn't be stored in the storage, for example, because of third-party incompatibility, something like that. Then you are able to create a custom storer, and I think it's a little bit hard to explain, but give me just a second to understand that. It's a long time I read this. Okay, so that means if the type equals company class and field.get type is an array, then don't store it. I think that's the point in this case. So you will be able to set the store behavior on the object. So it's the same down here. So you will be able to annotate special attributes within a class, and then you can say if this field is annotated, then use the store eager class, for example. So then you can enforce that this attribute will be stored with the store eager strategy all the time. That is also a great possibility to create some custom storing behavior within your application. Just try it out. it's nice to know that it's working like this, but yeah, it's up to you to use it. To be honest, I never used this before. But the next one is just jump into storing behavior. This is the related project. Custom company store, eager store. Yeah, this is the example. So I created a store eager annotation here, and within my customer object, I annotated the company itself, and that's whenever I store the customer, the company should be stored with the customer at the same time. And I think that's great to use it in a way. It could be quite useful in the future. Okay. Let's have a look to the last customization. Custom storing behavior. No, up and running. Yeah, custom type handler. This could be interesting for you. This is made for getting better performance by avoiding references. We have that case, especially when we consume third-party REST interfaces with huge transfer objects in it, or huge JSON files in the end. Some people said, okay, great, let's do object mapping, let's do a JSON object mapping, and let's store the objects in the end. But basically, in some cases, that makes no sense, because there are thousands of references within those JSON files, for example, and each reference costs a small amount of RAM. But if you consume that much information and you store that to the MicroStream, sometimes it makes no sense to create an object out of that JSON string. And sometimes it's much more, it's much smarter to just store the JSON string itself as one object and parse it when you need it. So that prevents you from having thousands of references within your MicroStream database. And mostly you wouldn't need those objects at all. So I knew it from my projects. We get objects, JSON objects, which thousands of child elements, and I only want to know 20% of that object. And I store the whole JSON object at once as a string, and I only parse it when I need it. And that makes a lot of difference. But there is another point, especially when you have something like that. You have a time slot class, which have an integer and two local date times. And the problem of that local date time is it consists of, it looks like this. Every time slot has its to and from. That means for every time slot object here, you have a reference to another object of the sort. And maybe there are some more sub-references inside those local datetime objects. And with a custom type handler, you can decide to make, let me check, let's go to the project, custom type handler. So here we have that time slot object. And when we, let me check, is there another branch in the, no. Time slot. Yeah, you have to add these binary type handler. And here you can decide whenever you add those handler types in the class times slot, it will be used by MicroStream. And you see here is a special mapping behind the scenes. And then you can store the time slot entity as one object, as a string, for example. So that means we have the slot ID. And then you see here, when the class is loaded, it transfers it to an instance of milliseconds. And that decreases the amount of references, which could be a problem, especially when you have a huge amount of references. Then sometimes it makes sense to use that custom type handler. But yeah, take your time, have a look on that product or on that project, and you will understand how it works. It's not that complicated, but yeah, it needs a little bit to see how it works. You will find all the informations also in our documentation to create such a type handler. And in some cases, it might be, it makes more sense to do the mapping by yourself. So it's also possible to do that. Okay, these are those special handlers. There is another legacy type mapping handler, but this is really complicated and not needed at all. So for some special cases. Okay, any questions to those customizations?
Sounds like tons of possible
Yeah,
issues here.
Tons of possibilities. Yeah, that is. But as I said, mostly we are totally fine with the basic stuff of MicroStream that works really great. And yeah, these are, I would say, most of that stuff is used when you have any corner cases or something like that. We did a lot of projects in the past with just the basic stuff, and it's totally enough. So and you will find many more examples on my GitHub repository, some Lambda category services if you want to use it. We have some more examples for how to store data to an AWS S3, for example. It's really easy to use it. Feel free to check out my GitHub repository. Maybe it helps. And as I said, there are many more videos comes up in the future, but we're still working on it. But yeah, now we are able to do this because version 7 of MicroStream is kind of like a huge major version, I would say. And now we can do some videos. Yeah, and I think that will help a lot also. We have one question from Frank. Is there a special strategy to operate with one central server-side storage and many different client-side storage on mobile devices? Definitely there is. We have such an architecture in place on the Frankfurt Airport, because all the baggage concealing system of the Frankfurt Airport is handled by MicroStream, and we uses MicroStream also on all the mobile devices for all the workers on the airfield. So when all the drivers they transport the luggage to the airplanes, they have those handhelds. These are Android devices, and they need an offline storage. And this offline storage is made with MicroStream also. So, but this is quite a lot of explanation to. There is a special strategy, yes, but it's quite hard to explain how this works.
If it's offline, how do they get updates? So basically so we have to synchronize the data all the time. That means, for example, when a worker starts to start working on a new airplane,
we synchronize all the data for this airplane to the device. And then it doesn't matter if the application is connected to the main server or not. It only works on the storage on the device. And in the background, we synchronize the data then all the time back to the server. But this is, yeah, that is quite a huge, yeah, it's really complicated. And it's quite hard to explain. And especially it's developed by another developer, so I'm not really into it. So, but so MicroStream consists of many more functionality, which is not open source at the moment. So that means we still work, or we work at the moment on the MicroStream cluster. So there is a replication in place. So we are able to have one write instance, for example, and several read instances. And whenever a write comes into the writer pod, I would say, the data will automatically replicate it to all the reader nodes of a Kubernetes cluster, for example. And this will be available as the MicroStream cluster in a few months, I guess. So 1 or 2 months, it will be final, hopefully. And we use that replication a lot in the background. So it is MicroStream is able to add some data in the background. Yeah, hard to explain, and a lot of rocket science, I would say. But yeah, maybe Frank, we can have a look on a different meeting. Then it's easier to discuss that. Okay, so let me check my presentation. Okay, I think we are here at the moment. So there is a performance demonstration in place. I don't know if you want to see it. It's up to you. We have enough time for question and answers. And I think we are 2 hours early, but that's totally okay. So we are just a few people. So that is quite normal that we are such fast, I would say. And we didn't have any lunch time, so that is also a big point. So now we have time for question and answers, and maybe I can start the performance demonstration. This is also really great, I would say. So give me just a few minutes to start this. Okay. This is the board itself. So just to explain the architecture. So we ordered 2, or let's say 3 EC2 instances in the AWS, on the AWS cloud. And on the first EC2 instance, maybe there is, give me just a second. I have a presentation also for that. That makes sense to show this. I have to find this. Advanced training. Oh. Maybe there is. No, okay, doesn't matter. So let's say we have one EC2 instance with MicroStream in it within a Micronaut application. And we have, on the other side, we have a PostgreSQL database, which has the storage also on the same EC2 instance. So both, that means that both storages are working on one EC2. And we have one sender application, and it sends REST requests to these other 2 instances. And we measure the time and amount of managed requests in this example. So, and all this stuff is measured by Prometheus and Grafana. So give me, where I have it. Okay, this is the Grafana board, and then let's go to, this is the demo application, but so if you have any question, feel free to write down the questions. So I will prepare the demonstration during that time. So, okay, this one, copy. Oh, oops. Okay. So I have to close some of that. This one is needed. Copy that. Okay. Yeah, here we are. Okay, so this is the sender application. So just a small application that sends data. And the first example is we have books around 1,500, not that much, with a title, value, author, and ISBN, a really straightforward query. And this query is with cache on both sides. So that means we have MicroStream in memory, of course, and we have the Hibernate cache on the PostgreSQL side. And now let's start the requests, and we should see the result here after a few seconds. Okay, so it starts. So you can see we have at the beginning, these are the calls or requests per minute at the moment. And to be honest, we are not able to, the biggest limitation is the sender application, because the sender application is not allowed to send more requests than this. But the important thing is how the responses are. And we have, I think it needs a little bit to measure the average. And I think that is not a really big surprise to see, okay, MicroStream is around, and this is a limitation. I think I'm pretty sure MicroStream is able to do a lot of more requests, or to handle requests. But you see here also Postgre flattens here, so that means we have around doubled the amount of requests that which is here. But the interesting stuff is this one. So you have a CPU consumption of 72% in this case, and we have CPU 6. What happens here? Just a second. Something is. Oh, now I think it crashed. Yeah, maybe I had to prepare that, because yeah, maybe my IT changed something in the background. So something. But yeah, just to explain, normally MicroStream would stay on under 10%. But can you explain what the differences is between the 76 or 67% CPU from the Postgre compared to the under 10%? Because both systems are working in memory, because Postgre gets the data from the Hibernate cache, and MicroStream is in memory normally. Do you know what the difference could be? Why is that the case? Have you an idea? Both systems are working in memory. Yeah, these are the right values now. Because it's the Hibernate object mapping. The mapping between the relational database or the relational data structure to Java objects. Because the cache of Hibernate is not an object cache. And you need to transfer or to map the data all the time. And that makes the differences on the CPU side. And this is why Postgre and other relational databases are such slow solutions mostly because of that data mapping all the time. And it's the same. We could start we could say, okay, let's load the data all the time lazy. Then let's stop this and let's say, okay, let's load it all the time without any cache on both sides. That is also interesting. So let's go to the lazy calls. We should have the results here in the end. Now I'm pretty sure we should see full CPU on both sides. Yeah. Yeah, I think something is wrong in the background. The instances are not working as expected, I guess. Huge differences, I would say. So you can see both CPUs are working, of course, because they have to load the data again and again. But the amount of requests and responses on MicroStream and PostgreSQL side are, yeah, really big differences. And there are some more tests for example, when we do a huge join call. So we're using, we get the graph we use join on PostgreSQL side and a stream joins on the MicroStream side. This is this one. So let's start. And this is also with cache again. So on both sides, you have the cache. Yeah, we have full CPU again on both sides. But see these differences, that is enormous. How fast MicroStream is. Yeah, in that case, especially, have around 7 times faster than. But I think, yeah, it's not the best to compare Postgre to MicroStream because the technologies are totally different, and maybe it makes more sense to compare, for example, DynamoDB or MongoDB with MicroStream. That is also possible, but we will see what happens with the cluster. The cluster, it will be really interesting how many requests we achieve with MicroStream within a cluster solution. Yeah, we have to find out. Okay, so I have one question on Frank. Yeah, Frank, unfortunately, there are no news on that. I have to check this, but it's on my note, and a lot of stuff going on this time. So yeah, I'm very busy at the moment. So I will check that with Strato. Okay, so let's start the last one, the average or the aggregate call. This is, I think that's only a count. Aggregate call, it counts the average cost of that 2,500 books. A small aggregate query. I think both will be increased till 1,200, and that's the maximum of requests we can send. But there is a small detail on that screen that is really crazy. Can you see that? Maybe can you see the differences of the average response time? The differences between the PostgreSQL and the MicroStream is really, I would say, sophisticated. That is. So if we had more time and much more power to send more requests, we would see the differences. But this is milliseconds versus microseconds, and that's really great to have those amount of differences. Okay, so if there are no more questions regarding MicroStream, then I would say we are finished with the training. Let me say thank you for your attention. Hopefully it was great for you, or it was a great experience for you. You get some, or you got some more information about MicroStream, and hopefully it's helpful to you. If you have any question, feel free to send me a mail. I will try to answer it as best as I can. See you next time.